Hi there. In the last part of our OpenStreetMap tutorial, we showed you how you can download OpenStreetMap building footprints and integrate them in your LimAQ model. In the last tutorial, we used a general building height for our model. And in this tutorial, we want to show you how you can derive building heights from digital surface models. So just to so just So just to remind you what the difference between a surface and terrain model is, a terrain model is what you usually work with when you are using or creating noise models. And the terrain model, as the name implies, is a model of the terrain. So it doesn't include the heights of vegetation and of buildings or of whatever might be on the ground at the time of the survey. A surface model, in contrast, includes the height values of the vegetation and of the buildings, and that is what we're going to work with now. So let's take a quick look at our surface model. Switch off all the other layers. So this is the surface model that we have downloaded for our project area, and if we switch off the building footprints, we can see that there are height differences where the buildings are and where vegetation is. And that is what we are going to use to assign height values to our building footprints. The tool that we are going to use is the zonal statistics tool. So if you open your processing toolbox, you can find it under processing and then toolbox, and then you type in zonal. That's already enough. You see under raster analysis, zonal statistics. It's a third result. So double click this one, and there you can select the raster layer. In our case, it's the digital surface model. It only has one band, so we're fine with this. Then we're using the building OSM file that we created last time. We don't need a output count prefix, and in the statistics to calculate submenu, we can select the statistics that we want to collect. So what this tool does is it takes a mask layer, which in our case is the building footprints, and it calculates the statistics that we can select here for the area of each mask. So in our case, for each building. So normally we just select the maximum values for the surface model, but we can also check all, doesn't make any difference. We run the file. Okay, so in the zonal statistics tool, we first select our raster layer, our digital surface model. Since we only have one raster band, we don't have to change anything here. And the vector layer containing the zones is our building OSM layer. And the output column prefix can be anything of your choice. We just leave the dash here. Then we can select the statistics to calculate, and we can simply check all. Okay. And so to explain what this tool does, it takes a mask layer, in our case the buildings layer, which includes or which contains polygons, and for these polygons it calculates the statistics based on the raster layer. So it takes all the values for each building, in our case the height values, and depending on what you select, calculates the sum, calculates the maximum, the minimum, etc. Okay, that's everything we have to set. Now click on run. Okay, and now let's take a look at our building layer. And here you can see all the statistics that have been calculated for each building. Now the statistics that we are going to use, or that we are going to work with, is the maximum, because in our experience the maximum value of the building footprint height data gives us the most accurate representation of the facade height. So to work with this information, we're going to create a new virtual field, a real field. We're going to name it Z. Okay, so let's take a look at our attribute table here. We can see that we still have the height values that we put in the last tutorial. So we put a general height of 8 meters for all the buildings. And then when we scroll to the right, we can see all the statistics that we have calculated. Okay, so what we're going to do, we are going to pick the maximum values and put them into our Z column. To do that, we open the field calculator, then we click on update existing field, then we select the Z value, and we select here from fields and values the maximum attribute field. So we click on OK, and now if we scroll to the left, we can see that in the Z column all the values have been updated from the ones in the maximum column. Okay, that's it. Now we can go to the 3D viewer and have a look how that is looking. Okay, so let's take a look at this in 3D. If you haven't installed the QGIS to 3JS plugin, go to Plugins, Manage and Install Plugins, and search for QGIS to 3JS and install it there. And then you can find it under Web, QGIS to 3JS. Click on the exporter. And then this might take a while depending on the model that you're loading and on the speed of your computer. Make sure that you have selected a terrain model as a reference. And then display the OpenStreetMap buildings. And in our case, we also have a survey model, level of detail 1. We're going to open this also to have a reference to see how our model compares to the survey model. Okay, so now we've loaded the buildings model that we created and also a building model that comes from a survey data provider. And now we can compare those two, how they compare. So I would say that that is a pretty good match. There are obviously some differences in the footprints. That is mainly because the OpenStreetMap data is most of the time more up to date than survey data. But apart from that, I think we hit the height pretty well. And the difference that you have to keep in mind between those two is that the survey level of detail 1 building model, at least in Germany, gives you the facade height only. And in case that you don't have a flat roof, the method of using a digital surface model will overestimate the facade height. But overall, I think that's a solution that is good enough for accurate noise calculation. And as long as you have the data available to you, it's a very feasible way to generate 3D building models. Okay, that's it for today. Thank you for watching and see you next time.